Yeah, we are still on the method of integrations, and then we are looking at the case of whereby the denominator resolve into rational factors. Okay, and in that case now, if the denominator is factorizable, then we use um, partial fraction as a first step before the integrations. So these are the following questions. Let's see how we can do that. Question one. Integral over 7x minus 4 all over 2x cubed minus 3x minus 2 dx. Let's check the denominator. If it's factorizable. Okay. This one times this one to get the product. That's minus 4x. This is s squared. This is s squared. This is s squared. Okay. That will be 4x squared. Then two factors of this. And when you add or subtract, you get the middle number here, which will be equal to 4 and 1. So how do you use 4 and 1 to get minus 3? So that is minus 4x and then plus what? Plus x. So, and then if you multiply these two, it will give you back this one. So then 2x squared, 2x squared, 2x squared, minus 3x. Uh, 3x minus 2 is equal to 2x squared minus 4x plus x plus 2. Then do the pairing. So here and here, 2x is common. Take it out, and you have 1x and then minus 2. Here, plus is here. 1 is common, then x plus 2. So then we now have x minus 2 into bracket 2x plus 1. Okay, so your integral now is now becoming 7x minus 4 all over x minus 2 into bracket 2x plus 1. So if you, there is a video which I made, please watch that video. It has given in-depth knowledge on the partial fractions. We discussed in that video the way you have a linear factors at the denominator, then to be equal to what? A over one of the linear factor plus b over 2x plus 1. Okay, so that's that. Then don't forget our question that the degree of the denominator is higher than the numerator. Okay, and your denominator is factorizable. Then that calls for partial fraction as a first step. Then multiply through by the multiply through by the common factor, which is what? X minus 2 into bracket 2x plus 1. So, and that will give us 7x minus 4. If you multiply through by this, you have for this one. Then this one, this will be a times this. That will be a 2x plus 1. Then b times this, b to bracket. So that's what you got when you multiply through. Multiply through by the common factor, you have this. Multiply through by the common factor, you have this. Then what we do now is elimination we're going to use, whereby we're going to ensure that one constant, this is a constant that was introduced to the question. This also is also a constant that we have to get. That we make a substitution for x value. We look at it, we expect it that what value of x we can use. That if you plug in one of the constants would cancel out. Okay, check it very well. If I put 2 here, b will go, then I can get my a. So let what? Let x be equal to what? 2. Then I have 14 times 2. That's 14 times 2. That's 7 times 2. That's 14 minus 4. And that's 10 equal to. Come back here. That will give us 2 times 2 plus 1. That's 5a. So a is what? A is 2. Okay. Then the next thing to do, what other variables, what other value I can plug in for x that will cancel a? Check very well. If I use half here, I'm going to get 1 plus 1. If I use minus half, this will be minus 1 plus 1. So let x be equal to what? Minus half. So, and that will be equal to 7 into bracket minus half, then minus 4. And that will be, this will cancel, then I have b into brackets minus half minus 2. Okay, minus half minus 2. So that will give us a calculator. So this will give me minus 15 over 2 equal to this one. This will give me minus 5 over 2 b. So 2 will go, 2 will go. Then b is equal to 1. B is equal to minus 15 over minus 5. And that's what. That's 3. So once you've gotten your a and b, then you go back to this place and make a substitution to that. So which will be equal to integral of 7x minus 4 all over 2x squared minus 3x minus 2 equal to integral of a is what? A is 2 into bracket x minus 2 x minus 2 then plus b, that's 3 into brackets 2x plus 1 dx. So the final answer will be equal to what? 2 ln x minus 2 then plus 3 ln 2x plus 1. And don't forget, there is a constant that multiplies your variable. So we have to divide by that constant. Okay, over 2 and then plus c. So that's that for question number 1. Okay, then we go to question 2. Question 2, we have integral of 3x plus 1 all over s cubed plus 2x squared plus x plus 2. Okay, let's first of all look at it very well. It is established that the degree of the denominator is higher than that. Okay, that's that. Then the next thing to do now, can we factorize it? Let's check. Do the pairing of the denominator. So s squared is common here. Okay, it will remain 1 here, and then that will be plus 2. Here, what is common? Plus 1 is common, and that will be s plus 2. Okay, so I'm having s plus 2 into bracket s squared plus 1. Okay, so you can see that my denominator now can be resolved into rational factors, which mean fractions. Rational factor mean fractions. Okay, so we now have integral over 3x plus 1 all over s cubed plus 2x squared plus x plus 2 will give me a over the linear factor s plus 2, then plus b over, this one is not linear, but it is quadratic. So multiply 2 by the common factor. Multiply 2 by, that will be equal to what? X plus 2 into bracket s squared plus 1, which is the same thing as this. Okay, it's the same thing as this common factor is the same thing as s cubed plus 2x squared plus x plus 2, and that will give me 3x on the left hand side equal to this one will be multiply this one times this one, a s squared plus 1, and this one times this one plus b into bracket s plus 2. So this is what we have. So we have many options to solve this question. We can equate coefficient, and we can also use substitutions, whereby we say let x be equal to minus 2, because if I put minus 2 here, b will be eliminated. Then I can get the other variable. So, and that will be equal to what? 3 into bracket minus 2 plus 1 equal to a into bracket 2 squared plus 1. That's what? Minus 2 squared plus 1, that's 4, that's 5. So this will be equal to minus 6 plus 1, and that's equal to what? Minus 5 equal to 5a. So a is equal to what? Minus 1. A is equal to minus 1. So that one is established. Then how will I get my b now? Okay, I can use any value. If I don't want to equate the coefficient, I can use any value. Okay, you can use any value, but let's equate coefficients. If you equate coefficient of, I need B now, coefficient of x, equate coefficient of x, okay, coefficient of, equate coefficient of x, okay, the coefficient here is 3, so 3 equal to, here, okay, we don't have coefficient of x here, but we do have it here, so that will be equal to what? Bx, so b is equal to what? B is equal to 3, which is very straightforward, b is equal to 3, okay, then the next thing to do is to plug in those values. Yeah, if we check what we got, we have one is a linear factor. The other one is not a linear factor, it's a quadratic expression. So in that case now, it's going to be a over the linear, then plus. This is quadratic, that will be b x plus c all over x squared plus 1. Okay, it's not linear, it's quadratic. Okay, please watch my video on partial fractions. I've given all the conditions, all the cases for partial fractions. So please watch that video. Okay, so this will be equal to, when we are here now, multiply through what? Multiply through by the common factor, which is x plus 2 into bracket x squared plus 1. So that will be equal to 3x plus 1 equal to a into bracket x squared plus 1, then plus bx plus c into bracket x plus 2. So what we have, that's what we have. We can equate coefficients if you want. X can be minus 2 here so that we can get the other values. Okay, let's do that. Let's x be equal to what? Minus 2. So this will go. So I have, this will give me minus 6 plus 1, that's minus 5. And this will give me minus 2, that's what? This will be 4 plus 1, that's 5a. So a is what? Minus 1. Then the next thing to do is to equate coefficients. Let's equate coefficient of x. Equate coefficient of x. X coefficient will be equal to, here, coefficient of x is 3 here. Let's check here. We don't have it here. This is bs squared, okay. And then bs squared. Then we have it here. Plus 2b, plus 2b, plus 2b, and then plus c. Okay. So that will not solve the problem. Let's just note that. Can we also equate the constant terms? If you equate constant terms, we have 1 equal to a. One here, we have a. Then constant terms here, this one, bs squared plus this one, 2b, then plus c, okay, plus 2c, okay, plus 2c. So we can use those two. So from here, 1 equal to a plus 2c. My a is minus 1, so minus 1, 1 plus 2c. Let this one move to that side. So c is equal to what? C is equal to 1 also. As this one move to that side, that's 2. So 2 by 2, c is also 1. So let's go to second equation. 3 equal to 2b plus c. 3 by 2b. C is what? Plus 1. I can go to the other side. So I have 2 equal to 2b. So b also is also 1. Okay. So we can now go back to the question. The integral of 3x plus 1 over x cubed plus 2x squared plus x plus 2 equal to, my a is what? A is minus 1 over x plus 2, okay, then plus b, my b is 1, and then my c also is also 1, okay, all over x squared plus 1. So you can put the integral here, put bracket dx. This one also dx. Okay. And the next thing to do now is to, so this will be equal to integral of this That will be minus ln x plus 2. The minus can go outside the integration. So integral of 1 over x plus 2 is just like integral of 1 over x is ln x, the next. Addition to that variable does not change the form of the answer. So this one, we're going to split this into 2. We're going to split into 2, which will be equal to integral of x over x squared plus 1, then plus 1 over integral of dx x2 plus 1 dx. So that's what we're going to do there. And then the derivative of this one is 2x. This is x. We can introduce 2 here and cancel the 2 outside. Okay? Then the final answer will be equal to ln minus ln x plus 2. Then plus half. The numerator is equal to the derivative of the denominator, and that will be ln x plus x2 plus 1. Okay? And then plus arctan x plus c. So that's our answer. Except we want to do some little adjustment here and there. And the adjustment could be to write the plus before, and that will be ln x squared plus 1 power half minus ln x plus 2, and then plus arctan x plus c. Okay? Then we can use a logarithm theorem, which will be ln. They have the same logarithm, and you have minus, that will be x squared plus 1 power half all over x plus 2. If you like, you can do it up to that stage. Then plus tan x plus c. So that's that on that question also. So that's that on that question. Yeah, we'll take one more questions. Yeah. Take one more question. We'll take the one that will be very fast so that we can divide this, can take the rest in the next video. So we'll go for this number 7. I think that will be very fast. We'll do that, and then we'll take the next, the remaining questions to next video. Okay, 7. Question 7. Integral of x plus 5 all over x minus x squared dx. So this will be equal to integral of x plus 5. You can factorize this one, and that will be x into brackets 1 minus x. Okay, so the denominator, if you check, the denominator is of power 2, which is higher than our numerator. So in that case now, and we also realize that the denominator is factorizable. So that will resolve into what? Partial fractions. That will be equal to, this one will be equal to, we now have now integral of x plus 5 over x into bracket 1 minus x equal to a over x plus b over 1 minus x. Okay, we can remove this integral first and get the expression. So then multiply through by the common factor. Multiply through by the common factor. By the common factor, x into bracket 1 minus this. So that will be x plus 5 equal to a into bracket 1 minus x, and then plus bx if you multiply through by the common factor. So let's x be equal to 1. So you have 6 here. This one we cancel. Then we have what? B. So b is 6 here. Then the next one, what can we do again? You can use any value. Let x equal to 0. Let x equal to 0. So I have 5 equal to a. I have a here. This one we cancel. Say it's 5. So you can see this one is very fast. Then finally, integral of x plus 5 over x minus x squared is equal to integral of a. A is what? We have a as 5. We have a as 5 over x plus b as 6 over 1 minus x dx. So that's what we have there, and that will be equal to 5 ln x plus 6 ln 1 minus x. But we must be very careful. We need to divide by these minus. So this will change to negative here, and I'll tell you why. Yeah, what happened is that just take this one for example. You have 6 can go outside. Then you have 1 over 1 minus x dx. Okay, so to force it to the standard rule, you can factorize minus here, and that will be equal to what? 1 over minus into brackets x minus 1. If you factorize with the minus. Okay, then you can take this minus outside, and that will give you ln 1 minus x. So the minus is outside, so this will change to what? Minus 6 and then plus c. So that's that on this question. So we've done question 1, we've done question 2, we've done question 7. So we have 4 more questions. So please join the next video for continuations of integrations that resolve into partial fractions.